Okay, guys, let's start. Okay, fine. So, just to give a recap, yesterday we have started understanding the percentile concepts. Okay, so we understood what is percentile. Fine. We understood what is quartile. What is quantile? Okay, quantile is just a generic term. Fine, but the actual terms which we are going to use are just quartile and percentile. Okay. So percentile is taking 1 unit at a time, P1, P2, and you can take till 100. Right? Quartile is taking 25 at a time, like P 25th percentile. Right? 25th percentile is called as quartile 1. 50th percentile is called as quartile 2. Fine. 75th percentile is called as quartile 3. Fine. 100th percentile is called as quartile 4. Fine. You will have 4 quartiles. Okay, this is 25th percentile. So you'll also have something called as quartile 0. Okay, the minimum value. Fine, we'll see those. So now, with this understanding, yesterday we were trying to see an example. Fine. So just to show you the example, for example, we have I told you that this is a formula which we can use. Fine. So if at all, for example, if at all this is just an example, so you never need to do this manually, okay, because you already have the formula. But since you're learning the first time, for example, if you want to find out the 50th percentile, okay, so 50 by 100 into 20 numbers, okay, count is 20, so you will have 20 plus 1 21. Okay, so if you do 50 into 21 divided by 100, 10.5. Okay, so 1 2 3 4 5 6 7 8 9 10. Okay, 16 is the 10.5. If you have 0.5, 0.5. Fine. So it is the, so this value is the 10.5. That is the index. This is the index which you got. Fine. So with this index, if you go and find the value, so it is 16.5. So as you can see, 50th percentile is 16.5. Okay, guys. So similarly, you can calculate all these values. Okay. So that is how you can do manually. But as I told you, this is just a formula for your understanding. You never need to do it manually. You always have the formulas. So for example, if I quickly show you over here, see 344,437, right? This is our data set. Okay, this is our data set. So over here you have percentile. Okay, so you have NP. NP is what? NumPy. Okay, NumPy, which we are going to study next. Okay, is a package in Python. Fine. So over there you have dot percentile. Okay, np dot percentile. If you do package dot module, you need to pass the data which you want to pass as input. Okay, d, and what percentile you want to calculate. Okay, I want to calculate 25th percentile and 50 percentile. Okay, so give just those. It will return two things. Okay, so as you can see, quantile 1 is the 25th percentile, quantile 3 is the 50 percentile. So quantile 1 is 8.5, 16.5. Okay, as you can see, 8.5, 16.5, 25th percentile, 50 percentile. Fine. So these are percentiles. Okay, as I've just told, 0th percentile is 0th quartile. Okay, 0 is 0 always. Okay, 25th percentile is also called as first quartile. Okay, 50th percentile is also called as second quartile. Okay, 75th percent is also called as third quartile. 100% is also called as fourth quartile. Fine. So you can call it as quartile 1, or 25th percentile is 8.5. Okay, or fourth quartile. Okay, you can call it as Q4, fourth quartile, or 100th percentile is 37. Okay, as you can observe that 0th percentile and 0th quartile is 3, Okay, and this is the minimum value which you are having over here. Okay, and 100 percentile is a 37, and this is a maximum value. Fine, but this is not always. Okay, this is not always, because this data is not having outliers. Fine, because this data is not having outliers, the minimum value is the 0th percentile and maximum value is the what, 100 percentile. Okay, but if it is having outliers, fine, we will see how it happens. Fine, but as of now, the plain data set, you can have the minimum value as 0 percentile, maximum value as 100 percentile. Okay, is this clear, guys? Let me know if you are good with understanding what is percentile, what is quartile, fine, how to calculate it manually, okay, and how to calculate it by simple Python code. Fine, it's simple, right? So you can any data set if you want to give, fine. Okay, see, for example, this is some random data, fine. So just pass in np dot percentile, okay, dd, and just give what all percentiles you want to find. Fine, it will give you. Okay, so in this, as I said yesterday, 50th percentile is also called as median. Agree? It's also called as median. So 50th percentile or Q2, 2 is what, Q2 is also called as median. Okay, fine. So I hope we are good with the percentile concept. Okay, quantiles. Okay, so now we will be mostly using quantiles. Okay, so going forward we'll be using quantiles. Okay, fine. So next thing is, see guys, now we have understood percentiles and quantiles. Okay, now as I said, now if someone gives us just a simple value like 85 percentile value equal to 10, if they say, so we have clearly understood that by the single statement we can understand that 85 percentage of the data is clearly less than 10. So we have an idea that okay, we are dealing with a range of data whose majority of the population is majority of the data is less than 10. Okay, so I am dealing with the data on the number scale from 0 to 10. 85% of the data is falling over here. Remaining 15 might be somewhere from 10 to 15 or 10 to 20. Okay, but at least I will have a some rough idea about the data because of this one single parameter. We have able to get that idea. Okay, now using this quartile. Okay, using this quartile. Okay, there are other applications also. Fine. So using this quartile, there are also other applications. Fine. So what are the application? The main application here is for the outlier detection, guys. Okay, for the outlier detection. Fine. So now before this, let's try to understand what is an outlier. Okay, before this, let's try to understand what is an outlier. Okay, very, very simple. Outlier is the an unexpected, or you can say abnormal item in the data. Okay, this is a rough definition. Fine. That means what? The outlier is, as I said, if at all uh, your column C1 is a heights of percents. So if you see 4, some 4.1, fine, 5, 5.2, these are fine. Suddenly if you see 10 or 50, okay, these are outliers. Getting? These are outliers because this does not seem to be belonging to this. Fine. This got included into this might be due to different reasons. Might be some human error or some system error, fine, or some code error. Due to any reason, this might have got creeped into this data set, but clearly this looks like it is not belonging to this data set. Getting? Suppose you are having a salary column, fine, fresher salary column. Okay, if you're seeing 50K, okay, that 30K, okay, or maximum 80K, that's fine. Suddenly if you see 50 lakhs, this looks like outlier, right? Outlier means what? A guy, outlier, that means a guy who does not seem to be belonging to the inside points. Okay, he is an outlier. Okay, this is an outside guy. Okay, simple meaning. Fine. Who does not seems to be belonging to this, right? Who is very, very different from the remaining data set. Fine. So those points are called as outlier points. Okay, basic definition. So in the initial class, we are also seeing that I said like when you're having 1, 2, 3, 4, 5, fine. So the mean will be 3. Fine. If you have 100, we have seen that mean is shifting to 16. Correct? Because mean is heavily influenced by outliers. Fine. So obviously, you can see there is a very much need to detect and handle outliers. Agree? Because if you don't handle outliers, the mean is getting shifted. Fine. If mean is getting shifted, everything gets shifted. Standard deviation gets shifted, because what do we have in standard deviation? We have x minus x bar. What is this x bar? Mean. And standard deviation is related to variance. Fine. Variance gets shifted, everything gets like affected. Fine. So it's very much important, and also the results will be very much biased. Fine. Because when you pass this type of data for a machine learning model, when you pass this, the model does not know this is an outlier, right? So it will also treat, okay, this is the actual data. This is also a part and parcel of the input data set. Fine. So it will also try to train itself based upon this data also. Fine. So it will also give results which are satisfying for this number also. Obviously, the results will become biased. Fine. Because originally this should not be the part of this. Fine. Due to some reason, this got introduced into this data. But if you don't handle and don't treat this outlier and pass as such to the model, obviously model will consider this is also perfect data, and the results which you get from the model are coming from, will do justice to this outlier also. Obviously the results will be biased. Fine. So that is the reason you should definitely keep an eye on the outliers. Okay, because data, guys, see one more reason why we are doing all this, because what is oxygen for the model is simply I said, if you give input, fine, it will give output. That's it. Fine. If you give input and output, sorry, if you give input, it will give output. Before that, before giving this, first what we need to do, we need to give input and output combination we will give to the model. Fine. To the model, it gets trained on this. Okay, it gets trained on this. If this is the input, this is the output. Okay, 1,000 rows. If let's say you are giving 10,000 rows, both input and output you will give initially to the model, it will understand the relation between these inputs and outputs for 1,000 rows. It will get some idea. After that, the purpose here is that we will just pass input, it will give output, because it has already got trained. Okay, so machine learning in simple terms. Fine. So now, as you can clearly see, the data is the main thing which is like playing a crucial role. Fine. If the data is disturbed, or data is not perfect, or if it is having outliers, or if it is having missing values, or if it is not scaled properly, right? So obviously all this will affect the model's performance. Fine. Because the input data is a main thing, obviously, for any model. Fine. To have like fruitful results. So that is the reason we are studying all this. Like, we are trying to understand what is the distributions of this one. What is if it is having any, as I said, if it earlier we have seen, if it is having null values, so how to fill it, right? So with the mean or median or some other values, right? Why to fill it? Because the data should be perfect. Fine. Ultimately, we are passing this data. The data should be perfect. But that's the reason we have studied like what is the best option to fill it with, mean or median or mode. Okay, in different categories. Now here also we came across another situation. The data should not have any outliers. Fine. Again, what's the reason? The data should be perfect before we send to a model. Fine. So this is one thing. Fine. This is an outlier. But there is an interesting thing. Okay. There are two things. One is actually called as noise, and second thing called as outlier. Okay. What are these? Noise is clearly unwanted data. Okay. This is clearly unwanted data. Fine. Outlier is an extreme data or abnormal data. Okay. We'll see what's the difference. Noise is unwanted data in the data set. Outlier is abnormal or extreme data. That means what? See, simply you will understand. As I said, in the column of heights, okay, heights column, you are having 4, 4.5, as I said 5, 5.5 something. If you see 50, fine. This 50 is what? Outlier, because this looks like abnormal. That means it's not normal. It's not like it's not very near to the other data points. That's why it's an outlier. But here, if you see, okay, here if you see some word called as mango, fine. This is noise. Okay, this is noise. Noise is completely unwanted data. This does not make any sense at all, right? Due to some reason, this word got introduced over here, okay, or some name got introduced over here, okay, fine. So, for example, if Virat, some name or some string, okay, some string got introduced over here, so which does not make any sense belonging to the remaining data set. Okay, that is absolutely noise. Okay, that is absolutely noise. Fine. Now, outlier is an extreme data. Okay, this looks like in the same category of the remaining data, but it is like abnormal and extreme data. As you can see, the range is here. Suddenly you see 50. That's not abnormal. Fine. Sometimes that if okay, now you got it right. What is noise and what is outlier? Outlier noise does not make any sense. Fine. Outlier looks like belonging to the same category, but the believability, yeah, that means you can't believe that that someone can have that value, fine, or something can actually possess that much value, fine, but it looks like it's belong to the same category, fine. If you take salaries sorry, take salaries of fresher, as I said, fine, 30K, 40K, 50K, 80K, okay. Suddenly if you see 10 lakhs, fine? Suddenly if you see 10 lakhs, suppose here if you see guys, in the salaries column, you are seeing this. Suddenly if you see a word called as IIT, okay. Now see here in this salary column, okay, in this salary column, these are all perfect values. 30,000, 80,000, 10 lakhs is an outlier, okay. 10 lakhs is an outlier. IIT is noise. Clear? Because 10 lakhs still it is an extreme value when everybody is just 30 and 80 or 50, 80, 60. This guy is like way high, right? He is an outlier. He does not belongs to this. He's not very close. He's not at least very close to the remaining values. Fine. But this is clearly what? A noise, because it does not belong to this category itself. Okay. Are you able to understand, guys? Let me know. Clear? Outlier, noise.
Yes, Santosh.
Okay. But now there is an important catch over here. See, observe here. See, it could be right. Someone who is entering these values, his job was to enter the okay. He got the data for each and every student. Fine. The what we say mark slip or salary slip. Fine. And he is entering these details. Okay. While he is entering these details, okay, by mistake, because the marks memo will also have, okay, the salary slip or the or whatever the receipt is looking into will also have the college name also, right? This guy will also come out of some college, this guy also some other college, okay. So suddenly instead of typing, okay, instead of typing the salary, okay, here type the college name by mistake, okay. Instead of typing the salary, he has typed the college name, okay. That's why you are able to see IIT, okay. That's why it's clearly noise, fine. But if you see the outlier, it is very abnormal or extreme data. But very interestingly, sometimes outliers are very much important data. Okay. Outliers will be the crucial data sometimes. Fine. It depends upon the domain, guys. That means, for example, if you see 30, 80, 10 lakhs, fine. So if you see this is an outlier, but this salary is possible. Fine. If for this guy who is coming out of an IIT, his starting salary could be 10 lakhs. Fine. So just because an outlier, that does not mean that is unreal. Okay. This is just not fitting into this data. Okay. But sometimes this could be like very, very important information it could be providing us. Fine. So this guy is saying this is actual salary, this is a way too high salary. Okay. But this is possible. Okay, for example if I tell you one more example, so let's see. If you are having the number of transactions, the column which you got is transactions column you got. Okay, and you are having the number which you are seeing over here is the number of transactions a person is making on his credit card. Okay, per 1 hour. Okay, per 1 hour how many transactions a person is doing, the count is this column. Okay, for example if you see zero, so that means what, he did not use the card for 1 hour. Okay, that's fine. If you see two times you have used. Okay, one. Okay, again zero. Okay, one. Suddenly if you see 50, guys, suddenly if you see 50, fine, this is an outlier. Fine, this is an outlier. Just speaking mathematically. Okay, speaking mathematically. Okay, just forget about the domain or practical or any concept. Mathematically if you see, all numbers are very near like 0 1 2, but this there is a high jump, huge jump from the remaining numbers, so obviously this is an outlier. Okay, this is an outlier. Fine. But what my point is, outliers are not always, not always, not useful. We cannot treat outliers are not always unuseful. Okay, sometimes outliers might be the very much crucial data, because the 50 transactions which you are seeing per 1 hour might be fraud guy. Okay, this guy might be the fraud guy. Fine, who is doing 50 transactions per hour, but as of now he is the outlier. Fine. So sometimes outliers are very much helpful in actually finding the like very, okay, very new patterns in the data, or very surprising uh, patterns, okay, in the given data. That means if you're doing 50 transactions per day, fine, obviously that looks like a fraud. And also if you see the number of amount getting deposited each day, suddenly if you see lots of amount, okay, lakhs of and crores of amount, if you reach sudden peaks in the data, right? So this is where it is very much helpful in, okay, in identifying outliers. And in some domains, I'm not saying every time it is useful, but in some domains this could actually be pointing to certain uh, unwanted or irregular patterns in the society. Fine, like some fraud, fine, or some theft, or some illegal activities, right? So you can clearly see a hike, right? Anything that is like going out of the normal things, obviously you should keep an eye out of it, right? Because everybody is doing, see, if everybody is eating like 3 times a day, if a person is suddenly eating 8 times a day, fine, just an example, everybody is 3 or 2 or 3 times a day, the person is suddenly eating 8 or 9 times a day, he's an outlier. He is definitely an outlier, but that does not mean he is unwanted. Okay, that does not mean he's unwanted. Unwanted is what? Unwanted is noise. Fine. So but outlier is not a noise. Fine. So if he's eating 9 times a day, it could actually telling us something. Maybe he is participating in some games, or he's an athletic, or he have some what do you say, championship coming soon, or due to some reason. Fine, but it will actually tell us a very specific trait of that event, or of that person, or the of that point. Fine. So that is the reason sometimes outliers are very much useful in finding out the, what we call it as, anomalies. Okay, anomaly detection they call it as. Okay, some, that means they will try to like very new or very different pattern what's happening inside the data, right? So it will help us to understand those patterns. Fine. But now coming to noise and outlier, see, can someone tell me which of these statement is true? All noise are outlier, or all outliers are noise?
think both are not true.
Both are not true. Okay. Others, any guess?
I think outlier considered as noise also, but noisy data not considered as outliers.
Correct. So, uh, kind of, kind of. See, all noise are outlier. This is true because every noise is an outlier. Okay, but every outlier is not noise. Okay, see, if you see IIT 10 lakhs, these two persons obviously they are not belonging to the remaining trend. Okay, remaining trend they're not following. Fine. So this guy initially you can consider this guy is also noise, this guy is also noise. Fine, but after that if you see now this guy became an outlier, this guy became an outlier, but this guy will still always be noise. That means what? Every noise, this guy, every noise, okay, is an outlier. Okay, but every outlier is not noise. Fine. That means some outliers are might be useful also. Okay, some outliers can also be useful. So because that's why every noise, this noise is not an sorry, this outlier, fine, this outlier is not noise. Okay, because he's useful, but every noise, okay, either you write anything over here that can be treated as an outlier. Okay, because that guy is not following the trend. Fine. So now coming back, fine. So yeah, so now this is a overall picture, guys, whatever I have told, but normally for now consider outlier as some extreme value in the given data set which we want to treat it and remove it so that the data is perfect, so that we don't have any deviations for the mean median. Okay, so fine. So are we good with the outlier, guys? Let me know if you have any doubts.
Santosh, like all outliers are nice, you said, right? But
All outliers, no, all outliers are not nice. All outliers are not nice because some outliers could be useful also, right?
okay.
Okay, fine. Now next thing what we are going to study is the box plot base, which is like extremely important concept over here. Okay, fine. See, box plot and outlier detection. So now from yesterday we are discussing a concept called as percentile and quartile. Fine, we are able to understand like that. So like how much percent of the data will be falling under a given percentile. Okay, we understood that. We understood quartiles. Okay, so that we can have four quartiles to have the to divide it by by the complete data. Okay, then we have understood something called as outlier. Fine. So now it's time to combine these two concepts. Fine. So in what does the quartile do? Quartile will try to, okay, quartile will try to tell us how much percentage of the value, sorry, how much percent of the data, okay, that is falling under each quartile, q1, q2, q3, etc. But if you remember, I have told you this is for the normal data. If at all you are having an outlier, this will not work. Fine, this will not work. So now to detect the outlier, okay, to detect the outlier, fine, outliers, you can use this quantile concept. Fine. So as I said, for the outlier detection, okay, for the outlier detection you are going to use this quartile concepts. Okay, for that we have a specific plot. Okay, specific plot designed based out of these quartiles. Okay, based out of quartiles only. What all quartiles we have discussed, like q1, q2, q3, q4. Okay, based, okay, based on these quartiles only we have designed a specific plot called as box plot, okay, which will help us, okay, to visualize the data. Fine, to visualize the data and also that graph will automatically give you the outliers, guys. That is a very important concept. Fine. So now we understood the quartile. Then we also understood the problems with outlier. So it's time to use this quartile concept to identify this outlier. Fine. Once you identify, then it's your decision whether you want to focus only on the outliers, okay, whether you want to focus only on the outliers or whether you want to focus on the remaining data. Getting, guys? See, as I said, as I said, if you're having if you're having in the heights concept, in the heights concept, so if you're having 4.5 something, like if you're having some height as 8 okay, based upon these concepts, okay, based upon this box plot, it will help us to detect the outlier. Okay, that means what it will detect? Okay, if you have 8 and 9 in the data, it will detect, hey, 8 and 9, these two are outliers. Okay, it will detect this. Fine. That is a usage of box plot. Using what it will do? It will using quartiles it will do. Okay, first thing. But now once we do that, once we have detected and identified outliers and separated them, now it is your decision what you are going to do next. Are you going to focus only, is your requirement, it's based upon your requirement, right? If your requirement is to focus on outlier, then what you will do? After detecting, you will focus only on this and you will try to understand what is the reason for these outliers and what is they are trying to say. Are they trying to okay, expose any very new or different unseen pattern? That might be your requirement, one. Or second thing is, you can simply remove these outliers and focus only on the remaining data and pass them to the model for further predictions. Fine. It depends upon your requirement. Okay, what you want to do with the outliers. Okay, but fundamentally, to do something, you should first detect what are the outliers. Okay, only then you can do some action on those. Agree? So now let's try to understand what is a box plot and how it will help us to give us something called as outliers, guys. Okay, fine. Uh, but before this, as I said, you need to have an understanding of what is an outlier, what is quartiles, what is percentiles. Okay, if you're good with these three things, box plot is nothing at all. Fine. So can you give me a heads up? Can I start box plot, guys? Honestly, everybody, are we good with the above three concepts?
Yes, Santosh.
Okay, fine.
Yes.
Okay, perfect. Now see, guys, box plot is very interesting box plot, and it is one of the plot which will directly help you in understanding the outliers. Fine. See, just try to understand. We'll try to understand. See, a box plot will look in this shape. Okay, so it is actually called as, even though it is just written here as box plot. Okay, just give me this. Let me take some color. Okay, fine. So even though it is written as just box plot, it's called box and whiskers plot. Okay, box and whiskers. Okay, WHIS, whiskers plot. Okay, what is whisker? Whiskers are those for the cat, right? So for the cat, on the mouth you'll have these hair-like structures. Fine, for the cat. So these are called whiskers. Okay, so they have discussed. They have so whatever you are seeing this, right? This, these are called as whiskers. Okay, this is a box. Getting? So for example, if I show you box and whiskers plot. Yeah, so if you see, this is a box. Okay, and these are the whiskers. Okay, and what is a whisker actually? So if you see whisker is, see the cat, whatever you have, these things. Okay, these hair like structures. Okay, so they've considered this is also something like that, so then they have named it. Fine. So but that is a origin of the name, guys. Fine. Now let's come back. Now this is a box, these are the whiskers. Fine, that is a name. So whenever you are saying box plot, always remember they're actually talking about box and whiskers. Its actual name is box and whiskers. Fine. Now let's try to clearly understand what is a box plot. It is very, very simple plot. So box plot is designed on a simple formula or a simple statement called as 5-point summary, guys. 5-point summary. Okay. If you are having, you need to have 5 points, then you can plot this graph. That's it. What are those 5 points? You see, box plots are summarized by way of displaying the distribution of the data based on a 5-point summary. First thing is a minimum number. Okay, see, minimum Q1, quartile 1, median. Median is what? Quartile 2, third quartile 3, and maximum. Okay, first minimum, second quartile, first quartile, that means second point is first quartile Q1. This is third point, this is fourth point, this is fifth point. First point is also called as minimum point. Second point is called as Q1. Q1 is just a 25th percentile. Third point is called as Q2 or median or 50th percentile. Agree? You're able to correlate, right? 50th percentile. Fourth point is the Q3 or 75th percentile. Fifth point is also called as maximum value. Okay, maximum value. Fine. So now, as you can see in this diagram, in this whiskers and box plot, fine. This the ending, the starting one, wherever you are having, right, there you will have minimum value, in minimum value. Okay, but this minimum value, right, this minimum value and maximum value, I will come back to. Don't assume what is the minimum, and it's not the minimum in the given data, it's not the maximum in the given data. Okay, we will calculate that. Okay, we'll see. But after, just try to understand the diagram first. So wherever you are starting this whisker, this like, see the you have this what we say, air pumping tool you have, right? For the cycle tires you have something like air pumping. So that sort of handle sort of thing which you have over here, that is a Q1 starting point. In this box is divided into 3 parts, guys. The first edge of this box is Q1. The middle part is Q2 median. The ending edge is called Q3, and the end of this other whisker, other handle, if you call it, right, that is a maximum value. Okay, that is a maximum value. Fine. So with this 5 points, you can draw what is a box plot. Fine. Q1, Q2, Q3, minimum, maximum. Clear. Now note, we need to calculate the minimum and maximum values. Okay, the minimum value and maximum value we need to calculate, guys. Okay, so we'll see. This type of plot is used to easily detect outliers. You can also tell us if your data is symmetrical, how tightly your data is grouped, and if and how your data is queued or not. Okay, perfect. So now observe carefully how this is helping us to give some what outlier. So see, guys, first thing is you will have something called as IQR, which is called as interquartile range. Can you see here? What is this? This is just quartile 3 minus quartile 1. Okay, quartile 3 minus quartile 1. Can you calculate quartile 3? What is quartile 3? 75th percentile. If given data, can you find out 75th percentile? Clearly you can do np dot percentile, give the data, and here you can use one value also. See, it's not necessary that you should always give 2 values. 75th percentile, I want to give Q75. Okay, 89 is a 75th percentile. That means this guy is a 75th percentile. That means 70%, 75% of the values are less than this number. These are the remaining 25 numbers. Okay, if given data, you can simply calculate what is 75th percentile. Okay, and that is Q3 minus what is IQR, only this range. That means Q3 minus Q1. What is Q1? Q1 is what? 25th percentile. So you can give quartile 25. Okay, give some name 25. Give some name 25. Clear? 68, very 68, 68. This guy is 25th percentile. So 70. Oh, sorry. What was 75th percentile? Guys, 89.
89.
Okay. So this guy, see, this guy is a 75th percentile and 68. This guy is a 25th percentile. So 75. Sorry, 89. Okay, 89 minus 68. How much?
21.
Okay, this guy is what? This guy is Q3. This guy is what? Q1. Okay. Now Q3 minus Q1. How much?
21.
2-1. Okay. This is what this is called as IQR. Okay. Simple example I'm showing over here. Similarly, if you go back here, any data set, whatever you are giving, you can simply plug in input out percentile. You calculate Q3 minus Q1. That is the IQR. Okay. After that, see guys, after that, you need to calculate two things. One is minimum, one is maximum. Okay. As I said, Q1, you see, median is Q2. Okay, that is fine. But as I said, Q1, Q2, Q3 are the values which you can directly get from the formula. But this minimum and maximum values, fine. This minimum and maximum values, you need to calculate. Fine. These are not the minimum and maximum values in the data set. Okay, that means what? This minimum is not the means sometimes it could be, sometimes it cannot be, depending upon whether it is having outliers or not. Okay, but the minimum value, you should not consider the smallest value in the given data set. The maximum value should not be considered as the maximum largest value in the data set. You need to calculate those. Okay, you need to calculate those. Fine. Why? Because see guys, try to understand, just try to understand this single point. If at all there are some outliers, where are the chances that outliers could be present? Mostly they cannot be in between, right? They cannot be in between. If it is an outlier, that means if it is deviating from the remaining data, obviously it should be very large than the maximum number or very small from the minimum number. Only outside of this data, outliers is possible. Agree? You cannot have some number which is in between these numbers and you cannot call them as an outlier because it is an insider, because it is almost very close to the remaining numbers. So if at all you are trying to call a number as an outlier, right? Obviously there are high chances that it should be outside of this pattern. That means it could be this side or this side. That means it could be very much greater than the maximum number or very much lower than the smaller number. That means even if you have something called as, let's say, minus 18, fine, this also looks like an outlier because it is very much smaller than the remaining smaller number 3. Or if you have something like 100, it also looks like an outlier which is very much greater than the maximum number. Fine. So that is a reason you need to calculate these values. Okay, that is the reason what we are doing here is minimum value and maximum value, the boundaries, edges which we are going to see, that we need to calculate first. Okay, because that is the reason we are not considering whatever the value, smallest number as a minimum number, okay, largest number as a maximum number. We are not considering those. We are using certain formula to calculate whether it is a perfect boundary or not. Based upon that boundary, we will see how to detect outlier. Okay, but Karthik, do you have some doubt? Because you unmuted.
So first, I mean, we will do sorting, right, on the data. So
Yes.
then only we can easily identify smallest and like outliers.
Yes,
That is the thing, right?
Yes, sorting is mandatory. That is
Oh.
done. Okay.
Fine.
Thanks for your, because yesterday also, the first point I mentioned is the data should be sorted. If you remember, data should be sorted. Right. So this is assuming that the data is sorted. Only then you will have the or percentiles, everything, whatever you need to do, right? First of all, data should be sorted. Then only if you see.
Correct. If you calculate median, then data should be in the sorted order.
Data should be in sorted order. Okay. If you say 50 percentile, if I say 50% of the data is less than this, which 50%? if the data is not sorted, whether this bottom 50 or top 50 or what 50, you will take bottom, I will take top. That does not work, right? So it goes without saying. Okay, by default the data is should be sorted. Okay, so now coming back. So we understood that first of all you need to calculate something called as IQR, guys. Okay, first of all you need to calculate something called as IQR. After that you need to calculate the minimum value and maximum value. Okay, these are also called as lower bound and upper bound, guys. Lower bound and upper bound. Okay, upper bound, lower bound. How to calculate? These are very simple. Lower bound is Q1 minus 1.5 times IQR. Simple formulas. Okay, maximum value is Q3 plus 1.5 times of IQR. Okay, that means what? You want to calculate now. This is done. You got Q1, Q2, Q3, and you also got IQR. That's fine. To calculate this value, okay, the minimum value, you have a formula Q1 minus 1.5 into IQR. Okay, that means what? You have the Q1. You can from here you can calculate Q1. Okay, into 1.5 times of this value, IQR value. You put it over here. You will get some value. Okay, you will get some value. That is your minimum value. Okay. Similarly, Q3 you have, see here Q3, 75%, Q3 you are using over here. That value plus, not minus, plus 1.5 into this IQR. Okay, you will have the maximum value that you put here. So now what we have? You have the minimum value calculated, which is also called as okay, lower bound. Okay, you have the Q1, you have the median, you have the Q3, and you have the maximum value, which is calculated, which is also called upper bound. Fine. So these 5 points. So as I said, box plot is just based upon 5-point summary: minimum, first quartile, median, second quartile, maximum. So you are able to calculate the minimum. You can clearly calculate Q1, Q2, Q3 from the simple formula, and maximum value you can calculate by this formula. To have this formula, you need to just have IQR. IQR is what? Nothing but Q3 minus Q1. Okay. Is this clear, guys? Are we able to understand different parts and values of box plot? Let me know. Any doubts over here? Okay.
No,
So
no, sir.
okay. So now, if at all given any data, if given any data, guys, any data, if you give, you manually can also, we will see, you don't need to manually, but always it is helpful to understand how you can do manually, right? So that you will have good thought process. Fine. So if given any data, you can simply calculate Q1, Q2, Q3, any Q you can calculate for that matter. Okay. Now are you able to understand why we are focusing on the quartiles? Because of the box plot. Why quartiles have become? Because out of all these, we have quartiles, quintiles, octiles, all these percentiles. Out of all these, the most famous, as I said, is percentiles and quartiles. Okay, because the quartiles have a specific application over here, which is helping us to detect outliers and handle outliers and solve many problems. Fine. So that's the reason it's very much important to understand what are Q1, Q2, Q3, Q4. Okay, best. So now we also understood how you can simply calculate for any given data. So now you can calculate Q1, Q2, Q3. From this Q1, Q3, from this Q1, Q3, you can simply get IQR. From this IQR, if you pitch in the values, you will get what is this minimum and maximum values. And now once we have this from the data, you already have Q1, Q2, Q3. Here you will plug in minimum, here you will plug in maximum. Fine. With this 5-point summary or with these 5 points, your box plot will be ready. You can also create. Okay, you can also create. You put a value over here. Okay, do this. Okay, you can also try to create a simple box plot. Okay, getting fine. So now, but how does this will help us to detect the outlier? That is the question. Fine. So now we understood how to what is a box plot and how it will design, but how does it will help to detect an outlier? Okay, it is very simple, guys. We have already done it. See, this is a minimum value or lower bound. This is a maximum value or upper bound. Fine. Now simply any value from the given data set, any value which is lower than the lower bound or higher than the upper bound or outliers. Outliers. Interesting. Any value So now that is the reason these are called as bounds. These are boundary. Okay. Using this formula, we have calculated and we have fixed this boundary. This is a minimum boundary. That means no value can be lesser than this value. This whatever the minimum value we are getting. If at all you want to include them in this data. If at all, if you find any value greater than this data, sorry, lower than this data, then that is an outlier. Similarly, I am fixing a boundary called as maximum by this formula, and I'm calling it as upper boundary. That means I'm saying no value should be greater than this maximum value if I want to include them in this data. If you find any value that is greater than this maximum value or upper bound, then that is an outlier. Okay. As you can see clearly, this dot, they are mentioning it as outlier. Why? This is lower than the lower bound. This is less than the lower bound. This is an outlier. See, these two are the outliers. See, these are greater than the, this is a boundary, but these two are greater than the maximum value. See, you are having outliers. Clear, guys? Are you able to understand the graph now?
Yeah, Santosh, clear.
Okay, fine, perfect. So now we will go here and I will show you two things. One is by graph how you can detect, and by formula also how you can detect, so that you will have a 360 degrees understanding. Okay, for example, let me say this is a data set. Okay, this is the data set, guys, some random data set. Fine, I want to find out the outliers from this data set. Agree? I want to find out the outliers from this data set. Okay, first thing is what, as Karthik has mentioned, sorted. First you need to do the sorting of this data set. Okay, just sorted is a keyword. Just do sorted, it will sort. As you can see, this is initially, this is some 11 10, as you can see 10 10 10 11 12. Okay, it is perfect sorted order. Clear? First step is sorted. After that what you need to do, guys, you need to calculate, see this formula. You need to calculate two things. What? Q1, Q3 and Q1. Okay, and what for what? That is IQR. Agree? See, guys, if you're able to understand, first thing is what? First step is just, first is sort. That's it. Second is calculate IQR. Clear? Third thing is using this IQR, calculate lower bound and upper bound. Okay, and based upon this you will get the outliers. 4 steps, simple steps. Okay, see, first thing is we have sorted. Sorting is done. After that, come here, calculate what? Next, calculate IQR. What is our IQR? Q3 minus Q1. Q3 minus Q1. What is Q3? 75th percentile. Q1 25th percentile. So first I need to calculate. So I'm taking from this data set. So 25th and 75th percentile. Okay, two values I got. Okay, what are these values? So actually, let me run again. Okay, so now 25, 75. Okay, these are the values. Okay, 12 and 15 are my 25th and 75th percentile respectively. Okay, this is done. This is done. Next, calculate. Okay, so no, Q1, Q3 is 1, Q3, Q1, Q3. IQR is what? Q3 minus Q1. Okay, that means what? Q3 minus Q1. Okay, Q3 minus Q1 is IQR. Okay, got it? Simple. 3 is my outlier. Okay, 15 minus 12, 3 is my outlier. Sorry, IQR. Okay, after that, this is done. After that, you need to calculate lower bound and upper bound. Okay, what is a lower bound upper bound formula, guys? Simple. Lower bound is what? See, lower bound is what? Q1 minus 1.5 into IQR. You can see here, Q1 minus 1.5 into IQR. Q3 plus 1.5 into IQR is maximum. It is just, once you calculate IQR, right? Just remember, you will multiply into IQR. For lower bound, you will separate it from the lower value, that is Q1. For the maximum value, you will add to the maximum value, which is Q3. Okay, to this Q1 you will separate, guys. With this Q3 you will add. That will give the minimum and maximum. Okay, just you can remember that way. So now if you see lower bound is what? Q1 minus 1.5 into IQR. Upper bound is what? Q3 plus 1.5 into IQR. Simple. You got two values. Fine. So now let me run this. You got 3. Now you got upper bound, lower bound. If you run this, you got 7.5 and 19.5 are what are the lower bound and upper bound of the given values. Okay, so now if you try to see what is my data set. Oh yeah, this is my data set. Okay, now if you see we will see how you can draw the graph, but okay, but if at all, what I will do is I can now what is an outlier, guys? We got this lower bound, upper bound. Any value less than lower bound is an outlier. Agree? Any value greater than upper bound is also an outlier. Agree? So now what you can do here is I will write simple for I in data set. Okay, for I in data set. Okay, if I is less than what? Lower bound. Okay, print I, and this is lower outlier. Okay, there is nothing called lower outlier, just for understanding it is less than the lower bound. Okay, similarly what I'm writing, if I is greater than the upper bound. Okay, I is this is upper outlier. Okay, now you see from all the values, from all these values. Okay, so it is saying there are 3 outliers and all are upper outliers only. Okay, 102, 107, 108. See these values, this bunch 102, 107, 108. Okay, you don't have and if you see the lower bound is and these are the values outlier. Why? Because our upper bound is 19.5 and anything greater than the upper bound will be an outlier. As you can see 19, see that's the reason you are having 19, right? So it has calculated 19.5 as the upper bound. So don't think the upper bound and lower bound whatever you are going to get will be present in the data, right? So that's the reason, as I said, that is the reason I said you need to calculate these values. These values might not be always present. This value, the minimum and maximum values, will calculate those. Okay, that might not be always present. Even the percentile also, yesterday I missed to inform a point. So even the percentile values also, that might not be all. See, for example, if you see, guys, here itself, what is this 25th percentile? What is the 25th percentile value? 8.5. Do you have 8.5 in the given data set, guys? Can you find out 8.5 over here? No, but 8.5 is a 25th percentile. So so the point here is the percentile values might not be always present in your data set. Okay, the percentile values whatever you are getting, even the quartile or quartile values also, fine. So that might not be always present. Sometimes it might be present, sometimes it not be present. Okay, fine. So but that is a value you need to consider. Even though it is present or not, you can say 8.5. Okay, wherever it is falling, even though I don't have this data, for example, I don't know, I did not see this data, but you are able to calculate this 25% 8.5. You can simply say 8.5 is a 25th percentile. That means 25% of the data should be, whether this 8.5 is present in the data or not, I don't know, but 25% of the data should be less than this 8.5. That's all. Getting? So even this C, for example, none of these C, sometimes it could be present. As you can see, 0th percentile is 3. It is present. That's fine. But if you see, for example, 75th percentile is 23.5. See, 23.5 is the 75th percentile. So I don't know whether this is present or not. I'm not sure. I don't see the data. But whatever be the case, 75% of the data must be less than this value called as 23.5. Okay. So as you can see, a 23.5 is not present in the data, but still this is a 75th percentile is somewhere over here 23.5 only. Okay. So the point is that these values might not be always present. Sometimes it might be present, sometimes it's not be present. Okay. So similarly, coming back over here, the minimum and maximum value which you are trying to see over here, fine. So the value which I got, sometimes it might be present, sometimes it's not. It's not. For example, what is the value I got? Lower bound is 7.5, 19.5. What is lower bound? 7.5. We don't have. Okay, we don't have. But based upon this data, right? What do you say? The system has said that even though it is 10, but still based upon the data distribution, it is saying 7.5 till 7.5. It will consider it as perfect number only, normal number only. That means even if you have 8 or 9, anything between 7.5 to 10 also, it will consider it as perfect number. That means it is not an outlier. Fine. But if you have something less than 7.5, then that will be an outlier. Yes. Okay, then that will be an outlier. Getting? Similarly, here also the maximum number, what it is there, the maximum number, where are we? Where are we? Where are we? Oh, yeah, the outlier, the upper outlier is 19.5. So here he is saying 19.5, even though the value, maximum value, like if you don't consider this, the value you're having 19. So it is saying till 19.5, okay, I'll consider till 19.5, I'll consider it as a maximum. Okay, that means what, even if you have 19.3, 19.1 also, that's fine. It will consider it as not an outlier. But anything greater than 19.5, definitely you will have, it will consider it as outlier. Okay, getting? So that's the reason you don't have any values less than the lower bound. That's why there are no lower outliers to that end. But here you can see clearly 3 outliers over here. Okay, getting? So now that's the reason you can see 3 outliers. So when we plot this, I'll show you how to plot. But as of now, just it is interesting to see when I'm plotting this data set. Okay, this is the same data set. See, as can you see these 3 guys standing here? These are the 3 guys, same as this. Okay, this 102, 107, 108 are these guys. See, 102, 107 and 108. You can also see this will be the 100. Fine, just greater than 100 is 102. Getting? And 107, 108 are very close to each other, obviously. So that's why these two guys are very close, a bit far from the 102 guy. Are you able to understand, guys? Outliers, 3 outliers we're able to detect from the given data. This is by formula, this is by plot. Clear? So given data, you can internally also see, internally also, how does this box plot will work? Internal also, what it will do? It will also do what all we have done, right? So taking the data, sorting the data, finding the quartiles, finding the IQR, finding the lower bound, upper bound, and checking these values. Whatever we are doing, if you plot a box plot, internally it will happen the same thing over here. It will only do, and then it will also tell you what are the outliers. And after that, it will also tell you these things. See, as I said, the box in this box plot, this is minimum value. Fine. Q1, Q2, Q3, maximum value. Okay. So here also, this is this whisker, minimum value. Okay. In this box, guys, I'm not sure if you can see in this box, there is one more small middle line. Are you able to see? In this box, blue color box, there is small black line. Can you see that, guys?
Yes, sir.
Yeah, this one. Yeah, that is median. That is median. That is Q2. The above one is this. This is Q3. The below one is Q1. Okay, and this whisker is Q4 or maximum. Sorry, it's maximum value. Okay, this is maximum value. Fine. So your Q1, Q2, Q3 you got. It will calculate, and IQR calculated. From that you will have maximum value. This is the plot we are getting. Okay. So now with this you can clearly detect the outliers just by simple plot. Even if you don't want to do all this above manual formula, you plot, just take the data set. See, you don't need to sort also. See, I'm doing, take the data set, come here, just do box plot of data set. That's it. You're getting by looking at this, only visually you can understand, hey, there are 3 outliers clearly. You can see. And one more important thing here is box plot importance is, one is to, as I said, you can clearly see here what is box plot to. Box plot will easily help us to detect the outlier. Okay, we understood that. And also it will also tell us whether the data is symmetrical, how much tightly your data is grouped, etc., etc. See, outlier we are able to understand clearly. It is telling. Other thing also, what it is telling here is, see, you can clearly see from this data, from this graph itself, you can clearly understand that the whole data which you are dealing is just between some, what is, if this is 0, this could be 10, okay, and this could be 20. So you are dealing numbers between 10 to 20. Agree? You got an idea. Whatever be the data, whatever be the number of values, right? But the maximum and minimum value, that the range of the data which you are dealing with is 10 to 20. Fine. You will get some rough idea. Clear? So that's about the basics of box plot. We did not completely discuss, but I think it might be getting late for you guys, right? So fine. So I hope you understood this. So tomorrow we are going to see actually how you can plot a box plot using the actual data. For example, we have seen this data, right? So cars data, right? Cylinders, everything. So for each column, how you can detect the draw a box plot and detect the outliers, and how it will change when you change the some columns over here. Fine. So tomorrow, you can join tomorrow, right, Meghna?
Yes, sir. We continue.
Yeah, so tomorrow will not take much time, so we'll take around like 40 minutes. Okay, if you can join at 6:30, we'll take around 40 minutes, so that we'll complete this concept, right? So whatever the remaining, the actual box plot on the data set. Okay, we'll see, and we'll see how many ways you can create box plot from numpy, from seaborn, etc. And then also we will see few other examples, like how it will detect, yeah, mainly how box plot will act in the case of outliers. Okay, so those things we will see, and some examples we will see. Okay, so that we can conclude box plot tomorrow, and softly we can start on the next topic on the Sunday. Okay, but I hope today we are able to understand what we are able to understand outliers, we're able to understand some percentiles, mainly we're able to understand box plots. Fine, are we good, guys? Okay, so I hope you understood the formula, and also how you can manually do it and find out the outlier, and also plot also you can clearly visualize. Okay, we'll go into much deep tomorrow. Okay, so are we good?
Yeah, Santosh.
Yes, sir.
Okay, fine. Take care, guys. Let's meet tomorrow. Bye.